In this lesson, we are going to be talking about proportional relationships. Let's first think about what a proportional relationship is. Suppose you and some friends plan to go to a movie and the tickets cost $8 each. You will pay $8 for one ticket, which means $16 for two tickets, $24 for three tickets, $32 for four tickets, and so on. The ratios of the total cost of the tickets is the number of tickets are all equivalent. A group of ratios that are equivalent are in a proportional relationship. When ratios are equivalent, they all have the same unit rate. In a proportional relationship, the unit rate is called the constant of proportionality. So let's think. How can you use a table to tell if a relationship is proportional? So we're going to use that same example, and we're going to take that example and look at it in terms of a table. The table below shows the cost of a movie ticket based off the number of tickets bought. For example, if you buy one ticket, it costs $8. If you buy two tickets, it costs $16. Three tickets, $24. Four tickets, $32, and so on. Circle the ratio in the table that shows the constant of proportionality. So remember, just above, we said that the constant of proportionality is the unit rate. And remember, the unit rate is when we find out how much it costs for one. So our constant of proportionality would be the ratio of 8 to 1, because it's $8 for one ticket. The ratios of the total cost of tickets to the number of tickets are equivalent. Remember, that means that they're equal. The ratios all simplify to 8/1 or 8. So the ratios are in a proportional relationship because they all simplify to 8. Remember, when we simplify these, we're simplifying them just like we do fractions. 8/1, or 8 divided by 1, is 8. 16 divided by 2 is 8. 24 divided by 3 is 8. 32 divided by 4 is 8. Or, if it doesn't divide evenly, when you simplify that ratio all the way down, it should equal the same thing throughout. The unit rate is 8. So the constant of proportionality is 8. So our unit rate and constant of proportionality are the two different terms that mean the same thing. The equation C equals 8t, where C is the total cost and T is the number of tickets, represents this relationship. The total cost is always 8 times the number of tickets. The table below shows the cost to play in the town soccer tournament. So we can see from the table, it costs $7 for a family of 1 to play. It costs $8 for a family of 2, $9 for a family of 3, and $10 for a family of 4. You can find and simplify the ratios of the total cost to the number of family members. So based off the table, our first ratio is $7 to one family member. 7 divided by 1 is 7. In the second ratio on our table, $8 for 2 family members, 8 divided by 2 is 4. Our third one, $9 for 3 family members is 3. 9 divided by 3 is 3. And then our last one, $10 for 4 family members. 10 divided by 4 doesn't divide evenly, but can simplify to 2.5. So all of these ratios simplify down to something different. So we can say these ratios are not equivalent. So the quantities are not in a proportional relationship. So when we divide these ratios out or simplify them, they must equal the same thing, or they are not a proportional relationship. Let's look at what this might look like on a graph. How can you use a graph to tell if a relationship is proportional? You can use a graph to determine if a relationship is proportional. The data from the cost of movie tickets and the cost to participate in the soccer tournament can be modeled by the graph. So you can see on the graphs we have points from our table. So the first point from our table with the number of tickets was $8 for 1 ticket. So you can see we went up to 8 for 1 ticket and we have our first point. Or $16 for 2 tickets, which is at 216. Or $3 for 24, which is at the point 324. Or 4 tickets for 32 at the point 432. In the second graph, you can see the total cost compared to the number of family members. So that second table we looked at on the previous page, 1 family member was $7, so the 0.17. 2 family members was 8, so the 0.28. 3 family members was 9, the 0.39. And 4 family members was 10, the 0.410. So what I want you to do now is to compare these two graphs. So just take a look at the two graphs and think how they're alike and how they are different. And maybe jot down a few of your ideas over here on the right. Pause the video and give it some thought. The points on the graphs are on a straight line for both sets of data, but only the data for the cost of the movie tickets goes through the origin. So remember, your origin is the point 0, 0. So this is the only line that goes through my origin here at this point. The one with the number of family members for total cost is higher up and doesn't pass through the origin. This means that only the total cost of the movie tickets compared to the number of tickets is a proportional relationship. So let's compare a proportional relationship and a non-proportional relationship. A proportional relationship, the graph is represented by a straight line, and the straight line goes through the origin. That means it's proportional because it meets both of these criteria. A non-proportional relationship, the graph may or may not be a straight line. It could be either one. A non-proportional relationship, the graph is a straight line, but it does not go through the origin. Let's reflect on this a little bit. Look at the graph that compares the total cost of the number of movie tickets you buy, the graph on the left. How can you use this graph to find the cost of 5 movie tickets? So there's a few ways you can do this. Pause the video, look at the graph, and write down how you think you could come up with the cost of 5 movie tickets. So like I said, there are several ways you could figure out how much 5 movie tickets would cost. One way is, by looking at the graph that the point 1, I have my highlighter. The point 1.8 represents the unit rate, or how much it is for one ticket. So based off of that point that's on our graph, we know that it is $8 for one ticket. And this was assuming that we didn't have the information from the previous page where it told us. Since we know it's $8 for one ticket based off the graph, I could then multiply 8 times 5 to see that it would be $40 for 5 movie tickets. You could also take a look at the graph, and I'm going to go back up to that graph, and we can see 5 movie tickets go up to where our line is and see that it meets our line at $40. So if we have enough data points, and for this one we did, we could connect those points to make a straight line that continues and use that straight line to make our prediction for 5 tickets. It would be $40. So that's 2 ways you could use the graph to help you determine how much 5 movie tickets would cost.